Actually, that was a good introduction. I forgot I wrote that bio a while ago. And just a personal story about that. Because I've been working in this stuff for so long, I've spent a lot of time seeing all of the stuff that are problems. I've seen them over and over and over again. And every time I would go to, say, PLM World Conference, which is sort of the equivalent of Cove for Unigraphics or NX users, I would always be asking questions, what is the key piece that I'm missing? What's the secret sauce that makes it so that all these problems go away? I always assumed, I guess I'm a humble guy by nature, I always assumed that there was something that I was missing, that the tools were there, and if I could just learn the method for how to use the tools, all this stuff would get better. And what I found was, over time, the problems never got better, and it wasn't that there was something I was missing. It was pretty much full understanding. It just simply didn't work. And what ended up being the problem, it was something that was solved a few years after I was starting to see these problems by Dassault. And even when I talked to some of the Dassault folks, I really did not get the full information about why they did what they did. And it wasn't until I talked to, I don't know if he's here, Rahul Suryadevara, that he basically sparked this in my mind. And it all kind of came to full fruition when I was mowing the lawn one day. That's about 2 years ago. So that's what these slides are about. I spent a lot of time talking about this with people inside of GE and multiple businesses, as well as outside. And these slides really are, after a year of doing those little conversations with whiteboards, what it is that was wrong with today that I always found annoying, and what I see as the future, what PLM should look like. And I'll even give you a little bit of demonstration, a couple of movies to play about what it could look like and what it does look like with the platform. So first thing is, what's the current approach and what is problematic with the current approach? So I'm going to go over that first, then I'm going to go over what the future really should look like and give you some demonstrations of it. Okay, so first is visualization. So one of the main benefits of having 3D is being able to actually see what your design looks like. But in reality, we have what's on the left. And our design is pretty much a tree structure of part numbers. It's parent-child part numbers all the way down the line. And nobody can really understand what that is. Even experts that have been doing it a long time make mistakes regularly. Are the right parts there or are they not? Because you're just looking at a list of numbers. It's impossible to understand it. It's not reflective of the real world. On the right-hand side is what my 9-year-old could understand. It's full 3D. If there's something missing, it's going to be glaring like somebody with a tooth missing. You're going to immediately see what the problems are. If there's multiple things that are overlapping, you've got the ability to see that. So I liken this to the movie The Matrix, for the people that are a little bit older that maybe have seen this from the late 90s. On the left-hand side, you've got what it looks like when you're sitting on the Nebuchadnezzar and you're Dozer or Morpheus. You see a bunch of characters falling. Only one guy could understand what that was. Something represents rubble or a machine gun or Neo, but only when you actually step into the Matrix and you actually see it in 3 does it make sense. So this is a major problem. We really do not have visualization, and we desperately need it. Another big problem, Samir Arora just went over this on a talk in the previous session, talking about what it takes in order to do collaboration. And so way back in the day, CAD was files on your machine. If you wanted to share them, maybe when they started to do shared drives, you could start to put them on the same location, but always you have to take turns. Anytime you edit a file, whether it's a spreadsheet or whether it's a CAD model or a Word document, all those things require you to take turns on those. And that's exactly the same with this. So here's an example of an NX assembly. And if we want to have these 3 different designers contributing to that assembly, they basically have to take turns. And as a result, I don't know what it's like in your businesses, we simply don't do this. What we do is we break further structure down so that somebody can control their own destiny at the lower levels, and thereby kind of eliminating this problem. But that's really a hack that makes things much more difficult to do. And then when you're constraining those pieces to each other, you now no longer have that possibility because now they're in separate substructures. So this issue of take turns collaboration is a pretty major one, and we want to be able to eliminate that so that we can have multiple people contributing to the same structure at the same time. So where are the different things that we do in order to work around this? I already mentioned one. So the first one is that we'll create sub-assemblies for no other reason than to divide and conquer. The other thing that we do is when we want to start depicting the geometries that we're designing in the context of the overall product, or we want to work around the fact that we made those substructures, we create additional CAD models that duplicate what really the product is. So we call these background files, and it's probably hard to read, but they actually have the number on them with a B in them because they're deliberately done as a collection of parts in CAD for defining what that background is. We're duplicating what somebody else is working on and putting it in yet another structure so that we can put it into that drawing as you see in that image. Everything that's highlighted in white is background. The only thing that is the actual parts in that design are a small run of green piping that's in the upper part of that. You can't even see it. It's buried. So this is all stuff that we take extra cost and extra work and extra risk because those things are not the same as the real one definition of the truth structure. Same thing happens within the assembly itself, not dealing with drawings. All the white that's highlighted, you can barely see them in between those cylinders. Those are the only parts that are being defined in that assembly. But they need the cans, those cylinders around them in order to constrain themselves and to work in context. So what did this designer do? They created 6 different support files. Those are additional duplications of the product in other files so that we can just simply do our job. All this stuff is a hack around this collaboration problem. So we do these background models for our assembly drawings 43% of the time. And what that really means is that I would say probably an additional 30% of the time, not only did you duplicate the structure, but there's not even a separate file. They just took a dumb copy of it and brought it in, which is even worse. So at least the folks that did it 43% of the time had it at least partially right, but they're really working around a basic problem. So the support assembly, same exact thing, 32% of the time people are doing that. That's all extra cost. It's extra cycle, it's extra risk because things can be out of date and you may not really be reflecting what's really there. Okay, so now here is the real big one. Configuration management by grouping. This paradigm has been around as far back as I can remember, and this is true for both part/BOM structures as well as CAD structures, which I'll get into that later. But let's just talk about, let's say we're still in the CAD world. What I've got here is an original design, and I'm specifying here, I'm actually pointing out to you that we've got the first 2 parts in that list are going to vary based off of configuration. So there's going to be some option that the customer chooses that would drive that part to be selected in that structure. So in reality, you would not see that at all. What you'd see is just a list of numbers. So you wouldn't have any idea what part is there and why is it there. You'd have no clue. I'm pointing this out because it's going to help me explain what this general problem is that I think we all deal with. The rest of the parts, which go from part 3 through 300, are, I'm going to say for this thought experiment, always the same. We're not changing everything. We're changing just those pieces. So let's say we have a different design that we need. We want to handle a different variant. What do? We clone the original structure, and then we swap out the parts that are going to be needed in order to support that particular configuration. And now you've got all of these parts up top that have driven you to do 4 different groupings where you've duplicated the vast majority of this. Now the problem gets worse. Now we want to make a design change that's holistic for all the different variants. Then what do? We clone again, but we clone all of them. And then we make the changes to the things that maybe they're in that common area where we want to now swap out because we've got a part that meets the same needs but we found it to be cheaper, a slightly different design, or there was a problem in the field and we're fixing it, trying to fix it for good. So now what we've done is we keep duplicating over and over and over again. And when this happens, it's just a lot of effort and it's a lot of difficulty. And as a result of this, we try to avoid doing this at all costs. One other thing that I'll mention here as well is that because I've got different variants, that means I need to find some way to program, ideally into a configurator, why I would pick those different groupings. Now I've got to go and figure out what that is and program that in manually in yet another structure, which is usually a product structure or a configurator structure. So in this case, what you've got is 87% duplication. Now the individual piece parts are the same, but the actual configuration of them that needs to go in for an order, where a lot of our effort is 87% duplicated. Once again, what the actual differences are between these is all hidden. You basically get a group, you get everything in it. We don't know that it's really those top two that are the things that really varied, because we haven't been explicit about it. We have no way to do that. So the rules become complex as well. The bigger you make the grouping, the more different variations could come together. Now you've got lots of different combinations. Now you have to make even more groupings. So there was a slide that Andy Colombi put up on yesterday morning where he said that they have, for Jaguar Land Rover, 10 to the 20th power of different configurations. That would mean a tremendous number of these as far as the eye could see. So here's an example of where we do that type of duplication. This is actually from our existing PLM and Novia database. So what we've got here is we've got 7 different groupings of this particular assembly. They've all got the same base number, so they're kind of the same. But then what we've got is, if you look closely at what's on the right-hand side, that is a textual comparison of the output of both of those bills of materials. And what we have here is that 104 out of the 111 lines are identical. We basically duplicated the whole thing. Almost the whole thing. The other piece about it is where the red arrow is towards the bottom on the left, we made one CAD assembly for it. Now, if you really wanted to see what it looks like in 3D, you would have had to have made 7 different assemblies. But we didn't do that. Because we know of the duplication problem, we just avoid doing it in all the places. We just do it on the BOM. And now your chances of having a 3D BOM evaporate. You'll never be able to see what that bill of materials looks like, not in 3D. Because it's more difficult, we just don't do it. Now, of course, a single level of a bill of materials is not usually where it stops. Bills of materials have multiple levels. So now you get into the problem of the bubble up effect when you now make one of those new groupings. So in this case, I've got this subassembly 1 that's used in 3 different places. If I want to make a subassembly 2, because I'm replacing maybe for a variant or maybe because just the product has changed, I want to replace part 4 with X4, I have to re-identify and make subassembly 2 just like I showed you in the previous slides. But of course it doesn't stop there. That doesn't go directly into the bill of materials. It goes in because there's an upper level to it. So now I got to go and re-identify those. And this bubbles up and up and up and up until you get to something unique that you don't have to change anymore. Extremely painful to do. This is the type of thing that makes very, very small changes difficult. So we had an example like this where we had already handled multiple different variations of one of our designs, and somebody figured out that we could save, I think it was something like $5,000 per unit to replace washers with something called a Nordlock washer because of installation purposes. I don't remember the details. We never did it. It would have saved us hundreds of thousands of dollars. We never did it because we knew we would have had to do all these things. The cost of doing that, you could not get return on investment because it's too difficult to do. So I call that the bubble up effect. I think I may have gotten that from somebody else, but I can't quote them because I can't remember. So here's an example of a more higher level duplication. So now we've got a higher level in our bill of materials, and it's very similar to the previous example, except now the duplication percentage goes up to 98.7%. And if you look at those bars, which are probably hard for you to see, there's almost no yellow. It's all white. And what it turns out is there's actually some detailed parts that we have different hole sizes for different customer conditions. That's the only thing that changed. But because of the way the paradigm of our systems work, you have to bubble up those changes and have re-identified numbers to handle configuration A and B. Smaller hole, bigger hole. Tremendous amount of effort. And again, as usual, we didn't create a CAD assembly for it. It's too much work. And this stuff is going to, I'm just seeing Nathan Yoffa here in the front. This is the type of stuff, this duplication at the instance level of these structures would kill you when you start thinking about connecting to other domains like manufacturing. So I'll be getting into that in a little bit. So here's another piece that has just been standard with our paradigm for many years now, is a separation of structures between CAD and between BOM. And a lot of this is historical. CAD started back in the 80s and 90s, and there were files on disk. We didn't have PLM systems yet. They didn't come around for a while. And so there was a file sitting on your computer. So that was the historical nature of it. When we started to figure out, hey, we can put this stuff on servers and use client-server technology to collaborate with each other, we basically just took the same files and put them up into the database. So we took structure that was on disk and we put the structure in the system. Now when you start thinking about it in terms of a bill of materials, that was a different thing as well, because that came from more of like an ERP orientation. You had a separate structure. And so these things were two separate. And even with Innovia today, we use 2012X, these are separate modules of the system that you can connect with each other, but as you can see, that's optional to do the configured groupings up top of those assemblies. They were optional, and we don't bother doing it in most of our cases. So a lot of this is really antiquated. The idea of these things being separate structures, in my mind, is antiquated. It's only because of historical reasons do we ever do this anymore. Because the underlying systems that we're integrating into PLM were file-based, and we moved them to a server. If you change your paradigm, this is one of the main things that I'm going to describe here when we get into the future stuff, is this needs a paradigm shift. Because this duplicate structures makes it so that you can make them, not do them together, and you end up having things that are wrong. All right, so good. Let's get into the alternate approach. And we're going to hit it in the same order. So visualization. Why is visualization so expensive? Main reason is that, just like I was saying before, CAD were files on your machine. If there's features and boundary representations that are stored in there, intermediate shapes in that construction process, they're all stored in the file. If there's a lightweight rendition of it in terms of tessellation, stored in the file. You put PMI on there, or what's called FTA in the Dassault world, stored in the file. Everything goes in the file. But if you look at, once these things become a database, why does it have to be a file anymore? It could be 3 files. It could be 8 files. It could be broken down into lots of little pieces. But in here, at least the first step should be, it's broken down into 3. Heavyweight for the person that's authoring the details or needs the boundary representation to constrain it in a product context. Lightweight for somebody that just needs to visualize it from a context perspective. And then really, really lightweight or thumbnail when you're dealing with something where you want to see the entire product, you don't need the details, but you want to get a feeling for what it is, and you want to use that as the basis to filter in order to work on a smaller grouping of that overall product. So this is the first and foremost problem with our visualization, is that you have to push ones and zeros of red and blue if really all you need to do is just get a basic idea of what that shape looks like. The best way to do it is stop sending those ones and zeros, only send what you need. It's kind of like the movie Spaceballs. Again, I'm dating myself again. But it's take only what you need to survive. Don't bother with all the other stuff that you don't need. One more time, I think. So here's an example in the 3D Experience platform where that was not sped up. It comes up that fast. That's an entire product. That's somewhere in the neighborhood of 60,000 instances of geometry are brought up on your screen at once. The only way to do that is to stop passing over the red and the blue and only take the green. So now the next part about this is, even before you start thinking about individual piece part files themselves and whether or not I need heavyweight or lightweight or thumbnail, the first thing is, am I even working on that? Am I anywhere near that? If I'm working on the engine of the car, I probably don't need the tailpipe for the car. So I want to be able to get to a smaller subset of what I'm working on. I would rather send not even the ones and zeros of the thumbnail, the green, that a little sliver I showed in the previous slide. I'd rather not even send that. I only need even the smaller pieces for the things that I'm actually going to be working on. So that's what this is about here, is that you've got a product, and I've got these red dots giving you the structure of it and what the pieces are. And if I've got a designer now that wants to work on that, they create a filter for themselves. They don't create their own assembly, as I showed you in the support files or background files. They filter the single structure that's there. By not having a file at that assembly level, you can simply repackage them and only grab the pieces that you need. Then, when they want to actually do their job, they can then add pieces to the structure where they see fit, and they can completely collaborate because we're no longer dealing with this take turns problem from before. That product node that's up top where that green item is getting added to is not a file anymore that needs check in and check out in the old days. It's just simply authoring a new item in the database for a new thing to go into that structure. And if I've got a second person, at the same time, they could have a different filter, and they could be adding their piece to a different spot in the structure where it makes sense, and so on and so forth. So completely changing the way that we think about how we do these things. Now, we no longer need to break down the product into lots and lots of little substructures just to divide and conquer. We can break them up from a modular reason. And people can just simply contribute at the same time to those things, rather than dealing with what we have today with. So here's an example of the filtering. Now here you have an example of, we don't just have one of our gas turbines in place here. What we have is, we've got sort of a piece of a power plant now with 4 different gas turbines in place. And if somebody wants to do the work on a portion of that, we want to be able to bring this up and define the region of interest that they're going to go work in. And so this is the volumetric filtering that's capable. In this case, I'm putting a box around one of the pieces. This is actually done by Loris from Dassault, who works in France. And as you stretch that box, pieces come into that filter or get filtered out as it changes. And then when you find the items you need, you then can say, that's what I want to work in. Then go into an authoring environment where you grab those pieces and go. Okay, so now this is the alternative to all those different groupings that we did. So here's just a rehash of the previous slide, except they're on top of each other. The original 4 up top with their variants, and below we've got the new 4 that are the same variants as the above, but because we did a design change. So rather than managing all of those with all those 2,400 instances, we instead have one max case in place. And now all of those items, 3, 4, 6 through 300, are not changing at all. They're always there. They're there one time, and I never have to worry about managing them when I create a new configuration. Every one of the other pieces is then controlled by what's essentially an on-off switch. You think of it, they think of it as effectivity is what they call it, but effectivity, I usually think of it as a date-based effectivity. But basically think of it as some rule that decides, is that part there or not? And those would be then connected in the upper parts to the variants, the options that the customer has chosen. And in the lower part, maybe an evolution of the product. Think of it maybe model year of a car. I replaced the tailpipe with a chrome one, and that is what is always going to be available for the next model year. You basically evolve it, but just make the one change. So this, just looking at this in this one domain, you're talking about 87% duplication removed. You basically get into it where there's only one of them, and again, this is going to pay dividends when you start thinking about it in terms of multiple domains. Because when you start connecting, the duplication will destroy you. So here's a max case example that we had just done recently. This is one of our inlets. And if you look closely at the image on the left, there's stairs, ladders, and the actual filter itself has multiple positions and multiple configurations, whether there's an evaporative cooler in there or if it's non-evaporative cooler. And then when you go to the right-hand side, that max case can then be filtered down to the individual pieces, the individual configurations, without managing any of the configurations. It's all just filtering that one max case. And this is an example from Samir Aurora that I got from before that I've been playing with for a while now. So here you have, it's a small brake assembly, but you've got those red pieces are all 3 brake drums for 3 different options, all in the same structure at the same time with different configuration reasons why they would be on or they would be off. And then when you go and you say, I want to explore it, it gives you a list of choices that are equivalent to the VIN number of your car. It gives you the exact, it's a number representation of all of the options you chose, what the model car was, what the model year was, whether or not you wanted a leather-wrapped steering wheel or something else is all remembered as a part of that VIN number, though they call that a product configuration. And then from there, you can immediately go pick the one you want and get right back to the result that you were originally looking for that we used to in the past manage with a separate CAD structure and a separate BOM structure. Now you don't manage them at all. You just simply manage the product and you grow it over time. So now we'll talk a little bit about how that affects when you start connecting across domains. And what I'm going to talk about here is connecting from an engineering structure, classically we call an E-BOM, to a manufacturing structure, which we would call an M-BOM. So if I've got an example from where I've got it like this. This is one particular configuration of parts in a BOM. I called it E1. If I want to repackage those into a separate manufacturing structure for our factory because they want to kit a couple of those parts together and kit another group together and then eventually assemble them in a manufacturing assembly up above, you basically have to map those items. You basically say, I'm going to consume that in this other spot. And if anybody attended Nathan's thing from before, this is what DELMIA manufactured item definition does. Now, if I make another grouping, and the only thing I'm specifying here is really the differences. This yellow part replaces the second red part, but now it's a separate grouping. In the classic sense, we have new instances for everything. So now when we want to do the manufacturing bill of materials, for 3 of the 4 items, we get into a Yogi Berra style deja vu all over again. I've already told you where I wanted that part. I told you where those 3s go. Those go in those different kits. But those have to be specific for that order as well. So now I've got 3 new manufacturing items just to manage where they go and the relationships in order to push them in the right spot. New E means new M. And so on and so forth. Here's a third example. So this is a very, very simple example. 3 different configurations that have 12 different components to them. The alternative to that, oops, too much. I got lucky. I thought I pushed it one more time. The alternative to that is everything becomes max case, including the parts on the manufacturing side. So now, when you get that second configuration where you've got the new item, all you're really doing is specifying yellow replaces red for that second slot. That's it. Then when you get to the manufacturing side, you simply have to resolve the new yellow. There's no deja vu all over again. It's the same red parts that were there before. No duplication of data whatsoever. And when the third one comes in, the third configuration, there's now another thing that has made this structure grow. So now I'm up to 6 different things that are within that max case. You simply tell it where it goes. And those kits now become max case. So rather than being 100%, they become, math in my head, 150% in this case. So far, far less data. In this case, just with this really, really simple example, across 2 domains, this is a 57% reduction if you count all of the components and all the relationships that you'd have to do on the left to achieve the same exact goal. And in reality, when we're talking about the digital twin that everybody, I believe, saw the presentation from yesterday, we're talking about connecting to low fidelity 1D models. We're thinking about connecting to more detailed analyses, connecting upstream so you have traceability from requirements. What are those but additional structures that need to be connected across domains? And so, I don't know if Chasen Bourne is in the room, but I got this story from him. Anybody heard of the story called Belling the Cat? The story is that there's a cat that's terrorizing a colony of mice in a house. And so one of the young mice comes up with an idea. I got a great idea. Let's put a bell on that thing. When the cat comes around, we'll hear the bell ring, we can all scatter. Everybody cheers. This is a wonderful thing. Great. An older, wiser mouse says, okay, who's going to put the bell on the cat? To me, this is what this means. All the stuff with digital twin, all the stuff with digital thread is belling the cat. It's asking someone to bell the cat. My team, we're the ones that have to put the bell on the cat. And what you're basically asking us to do is to do what's on the left. And the only way to get out of that in a real way, where you're making belling the cat easy, is to do what's on the right. And that means multiple structures like this that are connected across domains, and the duplication and new items as you go up the line, that's what's going to get you if you don't do it in the right. Here's another piece to it. Everything that we had talked about before, where you had these structures, basically would be duplicated in CAD as well, based off of the previous paradigm, as I showed. You have a CAD structure, you have a BOM structure, they're separate, and you can somehow sync them in good PLM systems. But again, why are they separate? Historically, because they were files on disk, as we discussed, that's why they're separate. But do they need to be separate anymore? What if they could be combined and they're all in one? This is what the CATIA V6 VPM platform does. When you have a node in that structure, the node in the structure is always a database object. If there's a shape to it, great. That CAD object rides along with that shape. But it is not one and the same that you then have to duplicate into another structure. Everything comes into one, which enables you to get out of the duplication of the duplication in different structures for CAD and for the bill of materials type of thing. There's one other thing here that also is very strongly related to the max case structures I showed earlier with the on-off switches. That there's actually a third structure that is also combined all into the same in order to get to that goal. And that's your product structure configurator. Almost every business that we have makes products that have variations to them. And what we do is we program manually a configurator as a third structure to the CAD and the BOM. A lot of people do this in actually different systems. So some people do it directly in ERP, for example. But either way, it's yet a third structure that now is separate. And what this allows you to do is that your configuration information, your bills of materials, your geometry are all in one big happy family, which makes it so that it's far easier to manage, and it guarantees that if their parts have 3D to them, you can see them from a bill of material perspective or from an enterprise exploration type of view. Doing pretty good on time, so I'm just going to go over some of the additional thoughts here. So I think it's fairly obvious that you really can't get to have this capability until you remove the classic stuff that we've got with CAD systems. The files, the basically bringing things down onto your machine and dealing with files rather than dealing with data is basically, it's fundamental in order to accomplish this. The other thing I wanted to go over really quickly is about change control and change management, because this is one of the things that comes up quite often when we talk about this initially. Anybody that has programmed configurators before knows that you eventually get wrapped around the axle. The rules become very complicated. You're basically describing if-then rules in order to decide true or false or on or off. That becomes very complicated, and if you're doing it by hand, it's very easy to make a mistake. In addition, which is probably even worse, is that if you have the possibility that if you change the rules, you could no longer go back and look at the 2012 Honda Accord and see the part in space, then we're going to go right back to what we do today, and we're going to save a snapshot of it as a separate bill of material or CAD structure. We don't want to do that. We want to have that be one structure that's filtered over time and based off of variation. The only way to do that, in my mind, is that change is what controls the rules. The rules get written by the change. And this is a more complicated topic, but it's something I just wanted to throw out there, because a lot of people are going to look at that earlier slide of those individuals collaborating on that structure and say, wow, this feels like Wild Wild West. You can't just go willy-nilly, have all these people putting things in different places that'll get out of control. But the reality is they would never do that. The collaboration would be orchestrated by change in a careful way to make sure that when these things go in, they go in as they're supposed to. And the changes themselves will be described in configuration language. So if you've got something where, in my example of, or Samir's example of the brake assemblies where those different brake drums exist, if you're adding a military version that's a beefier looking brake drum, the change itself, rather than typing by hand, oh, make a brake drum that's tougher for military purposes, you actually just explicitly describe that change with the option for military. Then when the person works under that change and then adds it to the structure, it immediately knows what the effectivity is going to be. It's an amazing thing to be able to do that. It basically gets you out of the manual problems that we've had in the past. It gets you out of breaking the past, and you get all the benefits of it. I think I've already mentioned this piece, the idea of the multiple domains amplifying the duplication problem. As I showed in that one with just connecting to the M-bomb, it was a 57% reduction simply across 2 domains with ridiculously simple examples. When you start connecting all the other things, how do requirements connect to my functional breakdown of my product? How do the functional breakdown connect to what logical architecture am I going to be doing, and how do those connect to each other? How do those logical schematics connect to the physical 3D part representations that implement those? You're connecting across multiple domains. And this problem of the belling the cat is going to really take hold there, is that if you don't do this in the right way, you're basically creating an enormous amount of data in a huge maintenance problem. We've never had that problem because we've never had the ability to really connect across domains. Now that we do, you really need to do it the right way in order to do it. Have even a prayer of doing it. I wouldn't even say efficiently. It's practically limited that you basically can't accomplish it. You just would get buried in the work. And even the manufacturing stuff doesn't stop at manufacturing items. Manufacturing items eventually lead to what is the operations and routings that are going to do operating to create those manufacturing items. And what are the work instructions that we're going to be doing? The domains, when you get down into the manufacturing space, the Delmia space, you start to get more and more structures and more connectivity across them. And it becomes very important, even more important, to stay in this max case, or what they call configured way. Another one that my friend Leo Florenzano's in the room, we've got an issue of how we do engineering analysis. Just to give you an idea how this stuff pervades not just the design and the part type of stuff, but we analyze what we have. We have tremendously complex things that have computational fluid dynamics, thermal analysis, and stress analysis needs, just to name a few. And what ends up happening is if you don't have a really good way to be able to analyze those groupings of parts, what do? You end up yet making another structure for those things. The data-oriented architecture can really make that problem go away, because the individual parts themselves could have multiple representations of their shape. Picture a beam having a 1D representation to describe the stiffness in the different directions and so on. Think of where the beam itself may have chamfers and blends on it that an analyst doesn't need. That's saved in the same model. Even if you've got the same model, you could have multiple fine element models that describe it. Fine, coarse, I want it refined around a particular zone. Those could all be placed on those individual 3D models. When you start thinking about bringing those together into an assembly, typically what we do today is every assembly analyst remeshes all the pieces. Now you would no longer have to do that. You basically just say, give me that one, give me that one, give me that one, and very quickly you've got your configuration. And all the stuff I mentioned before about the filtering for adding items to this CAD and BOM type of space, that same filtering can be used in order to define your analysis. So the actual analysis work, which we really want them to do, which is making sure you've got the right loads and boundary conditions and reviewing the results, they can then focus on that rather than building the models and building the configurations of those parts, with the risk that maybe I don't have the right part for this particular one because I had to create my own because I had no other way to do it. And so with that, I'm actually done with the presentation portion of this. If anybody has any questions, I'd be happy to field them. I think we've got a few more minutes. If anybody's interested in hearing more about this idea of max case and how that works, I highly recommend you attend the tutorial that Samir Aurora is doing this afternoon. That was one of the things I saw now was about 18 months ago, and I thought it was very powerful for explaining the basics of how things work. And he's going to do that example with the brake assembly, I believe.
No questions? Hold on.
Hold on, we need to wait for the microphone, otherwise they're recording and it'll look like I'm just standing up here.
The camera needs to pick it up.
So your 3D models, you know, and this is great, we're all for 3D models, but they're driven from configuration features, correct?
The 3D models as chosen to be a part of a product would be related to a configuration feature if they are.
Sure.
Does that answer your question?
Right, because if it's default, it doesn't maybe have a feature that drives it. So we
Right.
have 1,500 configuration features that drive our product
Yep.
today.
Yep.
Maybe it could be reduced, okay? Possibly it could. But you have to write a lot of rules and logic to maintain that. So that's what I'm saying.
Right.
It's a very difficult initial project to map all your configuration features to your models. I'm all for max case models. I think you know that. I've been max case model since 2005. So that's the way to go. It's definitely a better way, but you still have to write all those rules and logic. They don't just come for free.
That's true, but the one thing that I was mentioning from before is that the way that works in the platform, and the only really way to do it, is that those rules are done by change actions. So you would have a change that describes what it is you're doing. This is the one for military. This is for the 2015 version of the car. And what happens is when you work under that and then what they call officialize that change, it goes and it adds the rules to it, including modifying rules of other things that you might have removed from the structure as a part of that. So you'd have to take a look at it with me if you want to look at it a little bit closer. I'd be curious, since you've got experience with this. I would show you how that works. I've got a movie that I could play. It's like 26 minutes that show how that goes with the changes in order to accomplish that. I'd be curious of your feedback, but that's how I see that being really quite simple, because you're not really, for all these different instances, deciding what the rules are and hoping and praying you don't make a mistake. It actually happens in an orchestrated way with change.
So, and I think that's the detailed, fundamental change process for engineering on how to control all the effectivity. Some of the stuff that you're going to be interested in the application engineering is, the option to option, which ones are exclusive, which ones can be built upon each other, and the matrix that Kevin Bogney showed yesterday on how to manage those rules using this matrix rather than writing these Boolean expressions directly. Well, you don't have to write the rules. All you're doing is checking boxes saying, these things can apply and
Yeah, fair enough.
it is. It's just it's a user interface that makes it,
But I want to add one more thing to what you were saying. Typically, and I don't know what business you work in, but what you're really, what business? Okay. Okay, so you don't see this because you're removed from it. But what happens is that the configuration happens at a bill of material level, relatively high bill of material level. So what that means is that if you've got lots of combinations of rules that decide that grouping, you actually make your life a lot harder if you're managing the rules on groups, because you get a combinatorial effect. Okay. Well, but this problem is even worse than that. Some poor person on our team has to make the bill of materials. So you're really doing the rules at least twice, because they are the ones that have to decide what parts go into that structure. And if the customer asks for the chrome instead of the stainless steel and they get the wrong one, there's a problem. Somebody has to make sure the right stuff is in each of these structures. So it's actually, we're almost paying 2 or 3 times in order to accomplish it, in addition to all the other problems I was mentioning. But I still would love you to take a look at whether or not you think this would make that problem better or not. Okay.
I guess on a follow-up to that, what's your take on the max case bill of material as far as requirements? So if you have a meaty requirement or a ghost requirement, isn't that going to drive your max case to some ungodly, unmanageable piece? I mean,
That's a good point.
it's a different part because it's a meaty requirement.
Right. So media requirement, just for the people in the room, it has to do with an inspection of parts, right? Okay. So a couple of different things to think about there. Because of the way that the architecture works, we now get for the first time, arguably, to choose, does that really mean it's a new part? Maybe it's just a new inspection step. Maybe it's just a new operation in Nathan Yoff's world. And I cannot tell you the number of examples we have with this. I'll give you a great one. I'll give you a great one, just anecdotal. When we have a flange for a piece of pipe, we actually have 8 different flavors because there are rules that are customer specific, site specific. If it's going to be delivered in Canada, that part has to be stamped with something, right? And so what does that mean? That means that part stamping means a new fabrication that includes that flange. There's a kit that includes that fabrication. And then there's an arrangement that shows how all those different fabs go together. All the way up the line, 8 different times theoretically, we have to go and make new part numbers for all that stuff. Meanwhile, what's the difference? It's simply stamping and documentation. That's it. So think instead that it's just a 300-pound, 4-inch flange. And what we do is we implement that requirement in a different structure where it makes more sense, thereby completely eliminating that. So MIDI requirements I see very, very similar. We get to now choose, is it really a different part number or is it just a different operation in manufacturing that relates to that eventual serial number? But either way, the idea about it is that what you would, I believe, do is that you would make a change inside of, let's say, manufacturing space. And when you have that change, the change has its reason to support MIDI inspection. Then what you would do is you would go into the structure, swap parts out, just individual pieces that are affected, and walk away. No bombs, no CAD assemblies that are separate that you have to manage. No, once I make that group, go communicate to the configuration manager so that they can write the complex rules, all goes away. You basically make a change with its reason, swap, done. The change action stuff, I would almost argue, is the most exciting piece about this in my investigation into it. Great question, though. Frank.
Got my running shoes on today.
Okay. So I think you described that we should go away from file-based to putting everything as a byte data into a database, right?
Right.
So what do you suggest when it comes to platform agnostic for collaboration? So the byte data, would you suggest it should be a platform agnostic format so that we could even send it to suppliers who don't use CATIA or something?
Oh, that's a great question. So I have my opinion about it. I'd be curious of what Dassault thinks about it. The one thing that CATIA has and has had, I believe, for 2 years is they support STEP AP242. So that was actually on a slide from earlier, yesterday. And the beauty of AP242 is not only do you get the geometry, but you get the PMI, or what they call FTA, functional tolerances and annotation, I believe. You get that semantic, which means that it's not just lines or polylines that a human being can interpret. It actually says that there's a flatness, there's a dimension, there's a datum. It's completely specified, including the relationships to the geometry that you're specifying. So a lot of the stuff that we have now, the CAD system we use, will not, they say that they will support this in the next version, but I don't know if they said that last time. And so to me, the way you would communicate downstream collaboration with suppliers, sure, if they've got CATIA, great, that's fine, but of course we're not going to be able to force that. AP242 feels like a great way to go. The other piece about it too is that if you do the PMI type of aspects to it, the FTA, you get the visualization of that on the web for free. It's out of the box. You bring up the object in the web version of it, not even with the thick client or anything, and you see all of the views, you see all of the dimensions and so on. You even have light mock-up capability within it, so which is actually really, really cool. Right now we do hack workarounds with 3D PDF and with JT in order to try to accomplish the same goal, and we've had to customize it in order to make that work. So I thought that's fairly exciting. Oh, internally, how we would work internally, all the stuff I showed, I'm unaware of it working with anything other than what's now CATIA 3D Experience or V6. So I think in the long run that it feels like if you want these benefits, that's what you'd have to do. And the other CAD systems, they're left to figure out, are they going to try to follow this or what have you. Philippe?
Hey, Jeff. I loved your who puts the bell on the cat story.
Okay.
I know you've been leading the change on this topic in your organization for a long time. From your experience, what you've learned, would you share, if you were to do it again, what would you do differently to make this even more effective for you and your organization, adopting this change?
Okay, that's a really good question. And I probably would say I wish I was smarter. I wish I would have figured it out sooner. It's now, looking back on it, it's one of those things that's so obvious that, of course, there's really no other way to do it. The one thing that I guess I would mirror this back to you, Philippe, would be, this is a challenge, I believe, for the Dassault organization. The vast majority of people at Dassault do not understand what I've explained in this. I apologize for being critical, but they really do not. So what I would have loved if was not only 2 years ago when Rahul helped me spark this in my mind, but 6 years ago when I had somebody in my office trying to explain why we should move to CATIA years ago. I actually asked them explicitly, please tell me why you moved away from files and you went to data. Explain that value. The person could not explain it to me. Maybe I wasn't ready to hear it, to be fair, but they could not explain it. Something like this 6 years ago would have changed a lot of things, would have made a lot of pain go away for us, I think, a lot sooner. So I think we all just need to get better at communicating it, and I just wish I was smart. I would have figured it out quicker. I mean, this stuff is so clever to me that I'm jealous that I didn't think of it. I would have loved to have been the person that thought of it. I didn't.
All right, we have time for one more question.
Okay.
So this max case concept you described works with only with CATIA V6 and 3D Experience, right? So what would be a suggestion for the companies which have a lot of data in the older CAD systems?
Okay, that's a really good question because, of course, I'm forced to think about that because we don't use CATIA or even we don't use CATIA at all, let alone V6. So I've got an idea for a transition plan about how we go from where we are today to there. And there's multiple challenges here. First of all, just the basic format and needing to convert it. I think that's sort of the obvious one. The real problem, in my mind, wake up. It fell asleep. The real problem is going from those individual 8 groupings and making the one. That has to happen over time. That's a change that I would argue is even more complicated than just changing the geometry and repackaging it into a CATIA format. But I've actually thought through that quite a bit, and actually that might be a great topic for the next conference we have, because we're trying that now, is how we are, what the plan is for how we would transition, and how far we've come with that by the time we do the next conference. If somebody wants to invite me, I'd be happy to go over that. I wish I had a better answer, but for sure it's not going to be easy. And you have the Ford versus Chevy, Mac versus BC issue that will always pervade any of these things. You try to put a Ford person in a Chevy, and they're going to complain, even though, really, they're about the same. Sorry if there's any automotive people in the room. That's it.